Hi friends, good evening. My name is Sivendra Reddy. I am CSM department at Srinivasa Ramanyu Institute of Technology. Subject name Digital Logic Computer Organization. Today topic is process CPU examples. Process CPU example. Introduction to process CPU example. The central the central processing unit CPU is crucial for existing process in a computer. Understanding CPU process examples helps in optimizing performance and resource management. This presentation covers various examples of how CPU handling process in a different scenarios. Control unit CU, arithmetic logic unit ALU, registers, primary storage, main memory, secondary memory, output input, communication device CPU, central process unit. What is a process? A process is an instance of a program in execution encompassing encompassing program code and its current activity. Each process has its own memory space and system resources allocated by the operating system. Process can be in various states including ready, running, waiting, and terminated. Java program execution process. Types of process scheduling. Process scheduling is the method by which the CPU decides which process to execute next. Common scheduling algorithms include come, first served, FCFS, and round robin RR. These scheduling methods impact the efficiency and responsiveness of system processing significantly. CV scheduling, primitive, non-primitive. First one, primitive scheduling, longest remaining job first, non-primitive. Shortest job first, longest job first. Shortest remaining job first, round robin. First come, first serves. Highest responses, ratio next. Example of CPU multitasking. Multitasking allows a CPU to switch between multiple processes efficiently. For example, a user can browse on internet while simultaneously downloading files. This capability requires effective management of CPU time slice among active process. Browser, Excel, Point, Media Player. Process. Operating system, CPU. Multitasking. Context switching. Context switching is the process of storing the state of a process so that is can be resumed later. This operating is essential for multitasking and it is managed by the operating system. However, context switching incurs overhead impacting overall performance when done essentially. CPU. Process prioritization. CPU often manage processes based on priority levels to ensure crucial tasks revise the necessary resources. High priority processes can permit lower priority ones, affecting execution order and time. For instance, real-time application like video conferencing require higher priority to function smoothly. Time value prioritization funnel. Examples of IO by 0 bound versus CPU bound process. 1 by 0 bound process spend more time waiting for 1 by 0 operations to complete than using the CPU. CPU bound processes, on the other hand, require assignment CPU time for complications and processing. Understanding these differences helps in optimizing resource allocation and scheduling strategies. Difference between CPU and IO bound. Parallel processing. Parallel processing involves splitting a process to into a smaller subprocess then run simultaneously on multiple CPUs. This approach significantly reduces execution time for large computations and complex tasks. An example is a scientific simultaneous that utilize multiple processes to handle that vast data sets efficiently. Impact of virtualizations and process. Virtualization allows multiple virtual machines to run on a single physical CPU, enhancing resource utilization. Each virtual machine behaves like an independent computer running its own process. This technology is widely used in cloud computing and server management for better scalability. Conclusion and future trends. Understanding process CPU examples providing insights into efficient computing resource management. Future trends include advancements in AI driven process scheduling and optimization techniques. As technology evolves, CPU will continue to play a crucial role in how processes are managed and executed. Natural language processing. Thank you.